students, welcome back to my channel. My name is Prachi Sharma and in today's session we are working on the third part of important questions of the chapter Ammonia. So a lot of students told me that they find this chapter difficult. So I have provided a one-shot video on ammonia. You have a mind mapping video on ammonia and you also have 3 videos on important questions of this chapter. My target is to slowly provide you all the content for all the chapters that are there in the syllabus. So stay tuned for more content. So without wasting any time, let's get started with today's session. Alright students, let's get started with today's session. So the first question is, of the two gases, ammonia and hydrogen chloride, which is more dense? Name the method of collection of this gas. So for ammonia, if you remember the lab preparation, ammonia is collected by the downward displacement of air because it is lighter than air. But hydrogen chloride is collected by upward displacement of air because it is denser than air. So for the answer for this particular question would be hydrogen chloride is more dense. So first is that answer. The second part is saying name the method of collection of this gas. That means you're supposed to mention the method of collection of the hydrogen chloride gas. So that would be by upward displacement of air. The next question says, give one example of a reaction between the above two gases which produces a solid compound. So this, the equation that I'm gonna write now is an example for example, this question is asking above two gases which produces a solid compound. They can also ask you, give an example in which two gaseous compounds are combining to give you a solid compound. So that is also valid for that particular question. So let's quickly write that. So you'll have ammonia plus HCl, which will give you ammonium chloride. So that's it. Let's move ahead to the next question. It says, write a balanced equation for a reaction in which ammonia is oxidized by a metal oxide. So you can use any metal oxide, you can use a lead oxide, you can use copper oxide, and both of them would work. And the second one is a gas which is not oxygen. So ammonia is also oxidized by chlorine. So you can use that particular equation. So I'm going to write both of them here. So let's see. So for copper oxide, let's start with that. So I have copper oxide CuO plus ammonia, which will give you copper plus nitrogen gas plus water. And a gas which is not oxygen, I'm going to use chlorine. So NH3, that's your ammonia, plus chlorine will give you NCl3 plus HCl. So that's the answer for the second one. Let's move ahead. What do you observe when excess of ammonia is passed through an aqueous solution of lead nitrate? So a white PPT appears which is insoluble in aqueous ammonia. So that's your answer for this particular question. Name the substance used for drying ammonia. So that would be quicklime. Next is write an equation to illustrate the reducing nature of ammonia. So the equation that we did above, that was your copper oxide one. You can use that. Or you can use lead oxide. So in the above answer, I've mentioned the copper oxide equation. For this one, I'll write the lead oxide equation for you. So you can use lead oxide. So PbO plus NH3 gives me Pb plus nitrogen plus water. Okay. So I hope you're able to understand why we have the same answer. Because for the above question, they are saying, write a balanced equation for a reaction in which ammonia is oxidized by a metal oxide. So when ammonia is being oxidized by a metal oxide, then you're using copper oxide equation. In this question, they are saying, give an example in which ammonia is behaving as the reducing agent or the reducing nature. So in the previous case, if ammonia is being oxidized, that means it is also reducing something. So that is the reason you have the same answer for both of them. Let's move ahead to the next question. Which feature of the ammonia molecules leads to the formation of ammonium ion when ammonia dissolves in water? So ammonia has the nitrogen that you have in ammonia. It has one pair of lone pair of electrons. So when we mix it or when we dissolve it in water, that lone pair helps in the formation of ions when ammonia is dissolved and in the formation of ammonium ion. Then the next question is, name the other ion formed when ammonia dissolves in water. So one of the ion is ammonium ion. And since we know ammonia gas is basic in nature, it is alkaline when you mix it in water. This means that you would also have hydroxyl ions, that is OH negative ions. So the other ion formed here would be hydroxyl ion. Then the next is, give one test that can be used to detect the presence of the ion produced in a second part. So they are asking for the hydroxyl one, that is OH negative. So you can use any test that you know for bases and you can put that here. The one that I would suggest would be moist red litmus paper turning blue. So that would work perfectly fine. The next question is, write the equations for the following reactions which result in the formation of ammonia. The first is a mixture of ammonium chloride and slaked lime is heated. So let's write with that. So slaked lime is CaOH whole twice and ammonium chloride, that is NH3 Cl, and we are forming ammonia. So when this reaction will happen, you will get CaCl2 plus water plus ammonia gas. Then the next is aluminium nitride with water. So always it's warm water. So that should be mentioned in the question, with warm water. If not, then when you're writing the equation, you can mention warm water below where you write water. So that would be ALN plus water. You can write warm right here. And then this will give you ALOH whole thrice plus ammonia gas. So that's your equation. Let's move on to the next one. Question 5a part. Name one element in following case to which the following description would apply. So the first part is the burning metal which combines directly with nitrogen. So you have multiple answers here. You can use any one of them. So when we are talking about a burning metal which combines directly with nitrogen, you can have magnesium, calcium or aluminium. All three are perfect answers. You can use any one of them. Then the next question is, name the gas that you can obtain in the lab from each of the following and write the equation for the reaction. And they are saying ammonium nitrite. So ammonium nitrite, we just saw the equation. So that was, where is it? Ammonium nitrite. So that would be ALN plus, what was the equation that we just wrote? Plus water, which will give you ALOH whole thrice plus ammonia gas. Then from ammonium chloride, so that will be NH4Cl, and what will that combine with? It will combine with NaOH, and this will give you NaCl plus water plus ammonia gas. Let's move on to the next question. Distinguish between the following pairs of compounds using the test given within brackets. So iron 2 sulfate and iron 3 sulfate using ammonium hydroxide. So how will we differentiate between that? So if we talk about iron 2 sulfate, so you have a dirty green PPT which eventually turns into reddish brown PPT, and this is insoluble. This is insoluble in excess of ammonium hydroxide. Whereas if we talk about iron 3 sulfate, so that's a reddish brown PPT and it is insoluble in excess of ammonium hydroxide. Then the next question is lead salt and zinc salt. So one important thing is that lead and zinc salt, both of them with ammonium hydroxide, will give you a white PPT. But in the brackets, that is the reason they have specifically mentioned that we need excess of ammonium hydroxide. So when you're using excess of ammonium hydroxide, your lead, the white PPT that lead will produce, that will be insoluble, whereas the white PPT that zinc will produce, that will be soluble in excess of ammonium hydroxide. Students, if you have any issues with these type of questions, I would suggest that you check out the analytical chemistry video in which I have discussed the method, how you can learn this and how you can apply that in questions. So make sure that you check that out if you have any issues in learning the color of PPTs, in which you have issues with using ammonium hydroxide regular and in excess. So for any type of questions that you're struggling with, you can check out that particular video. Alright students, let's move ahead to the next question. So the next question is, So the next question is, we covered up till the 6th one. So the next question is, name the following two compounds heated together in solution to produce nitrogen. So the two compounds that you can heat together will be your ammonium chloride and sodium nitrite. So ammonium chloride and sodium nitrite. So this will give you nitrogen gas. Then the next question is, what do you observe when ammonia gas is bubbled through red litmus solution? So your observation would be that the solution will turn blue. So that will be your observation. The next is, explain why the following statement is not correct. So the question says, the statement says, ammonium salts on heating decompose to give ammonia. So that's wrong, because not all ammonium salts will decompose to give ammonia. That is because some ammonium salts, that for example ammonium nitrate, can give you nitrous oxide instead of giving you ammonia. So that is the reason this statement is wrong. So you will say all ammonium salts on heating do not liberate ammonia. For example, ammonium nitrate will give you nitrous oxide. So that will be your answer. The next question is, write balanced chemical equation for the following reactions. Ammonium chloride solution is added to sodium hydroxide solution. So we just did that, but I'll still write the equation for you. So ammonium chloride will be NH4Cl plus NaOH, and if we heat that up, we end up getting NaCl plus water plus ammonia. The next question is, copper sulfate solution is added to ammonium hydroxide solution. So CuSO4 is being added to ammonium hydroxide. So NH4OH will give you CuOH whole twice plus NH4 whole twice SO4. So that will be your answer. Now let's move on to the next question. Study the figure given below and answer the questions that follow. Identify the gas. What property of the gas Y does this experiment demonstrate? Name another gas which has the same property and can be demonstrated through the same experiment. So let's closely look at the diagram. So the diagram is saying that we have a blue litmus solution. We have a dropper, we have a spray, and gas Y is present and water dropper is there. Okay. The first thing you should understand here is that you have a blue litmus solution in this particular trough. So that means we are not talking about ammonia gas here. We are talking about hydrogen chloride gas. So first answer for the first question, identify the gas Y, will be hydrogen chloride gas. The next question says, what property of gas Y does this experiment demonstrate? It demonstrates high solubility or extreme solubility of hydrogen chloride in water. The third part of the question is asking, name another gas which has the same property and can be demonstrated through the same experiment or a similar experiment. So that would be ammonia gas, because you can also identify that by using a red litmus solution in the trough, and then eventually you end up seeing a fountain which is blue in color. So let's move ahead to the next question. The next question says name the other ion formed when ammonia dissolves in water. So we just did that question also. So the other ion formed would be hydroxyl ion. The other question is, give one test that can be used to detect the presence of the ion produced. So the answer for that would be, you will be using moist red litmus paper which turns blue. So this confirms the presence of hydroxyl ion. Let's move ahead to the next question. State your observation when ammonium hydroxide solution is added drop by drop and then in access to each of the following solutions. So the first is copper sulfate solution. So copper sulfate solution is very clearly understood that you have a blue colored precipitate that appears and that dissolves in excess of ammonium hydroxide, giving you a pale blue solution. So that's what's going to happen for the first part. The second part is zinc sulfate solution. So in this case, we'll have a white PPT that will appear and which will dissolve in excess of ammonium hydroxide solution. Okay students, let's move on to the next question. This says the complete and balance the following equation. So as I do in all the all the questions. I won't be balancing the equations. You'll balance the equations, and if you have any doubts, you can reach out to me. So let's start with the first one. Ammonia plus HCl. So ammonia plus HCl will give you ammonium chloride, that is NH4Cl, which is solid. Then the next one is ammonium hydroxide plus HNO3. So that will give you NH4NO3 plus water. Ammonia plus oxygen will give you, so one of the product is given, it will give you water, and one of them they are asking, so that will be nitrogen. Then the next is lead oxide plus ammonia. So we covered this equation today as well. So this will give you lead plus nitrogen plus water. The next is ammonia plus chlorine, and in this case your chlorine is in excess, so that will give you NCl3 plus HCl. Let's move ahead to the next question. Write balanced chemical equations for the following, and the first one is ammonia is prepared from its elements. So ammonia is prepared from its elements in Haber's process. So that means nitrogen plus hydrogen gives you ammonia, but make sure that you mention all the conditions on the arrow. So that would be, let me write that. So that would be nitrogen plus hydrogen giving you ammonia, and then you mention all the conditions. So you will say lead, there is iron, there is molybdenum, then you will say it is 450 degrees to 500 degrees Celsius, it is 200 to 1000 atm. Let's move on to the next question. It says ammonium chloride rod dipped in concentrated hydrochloric acid is brought in contact with ammonia. So that means ammonia NH3 plus HCl will give you NH4Cl. Then the next is sal ammoniac reacts with slag lime. So what is sal ammoniac? So that is NH4Cl, and what is slag lime? That is CaOH whole twice. So let's write that. So NH4Cl plus CaOH whole twice will give you CaCl2 plus ammonia plus water. Let's move to the next one. Reduction of hot copper oxide to copper using ammonia gas. So that again we have done. So CuO plus NH3 will give you copper plus nitrogen plus water. The next is action of warm water on magnesium nitrite. So magnesium nitrite is what? It is Mg3N2, and you are adding warm water to that. So that will give you magnesium hydroxide. So MgOH whole twice plus ammonia gas is liberated. Then next is lab preparation of ammonia using ammonium salt. So the equation that we have done today, that is your sal ammoniac. So you can use the same equation. So that will be NH4Cl sal ammoniac plus you can use slag lime, that is CaOH whole twice. That will give you CaCl2 plus water plus ammonia. The next question is reaction of ammonia with excess chlorine. So in this case your chlorine is excess again. So what will that give you? So ammonia plus chlorine in excess, that will give you NCl3 plus HCl. The next is reaction of ammonia with sulfuric acid. So that means ammonia plus sulfuric acid is H2SO4 will give you NH4 whole twice as SO4. The next is when excess of ammonia is treated with chlorine. So you have ammonia NH3, this is in excess, and you are reacting that with chlorine. So in this case what you will get ammonium chloride plus nitrogen gas. Then the next question is an equation to illustrate the reducing nature of ammonia. So we have done lead oxide, we have done copper oxide. So let me give you an equation for zinc oxide. So that will be ZnO plus ammonia will give you Zn plus nitrogen plus water. Let's move to the next one. Action of warm water. Oh yeah, we have done this one also. So you have aluminium nitrite plus water, which will give you aluminium hydroxide plus ammonia gas. Alright students, let's continue further. So we were on question number 13. Identify the acid which matches the following description. The acid which is prepared by catalytic oxidation of ammonia. So that will be nitric acid. The next is the acid on mixing with silver nitrate solution produces a white PPT which is soluble in excess of ammonium hydroxide, that is dilute hydrochloric acid. Then the next question is, you have two columns given to you. So a promoter used in Haber's process is molybdenum. So that is C. Catalyst used in oxidation of ammonia. So what catalyst we'll use? We'll use platinum in the oxidation of ammonia. It's in Haber's process. So that will be E. Drying agent for ammonia. So that will be calcium oxide, F. A solution which gives brown coloration with ammonium salts. So that is not in the syllabus. A solution which gives brown coloration with ammonium salts. So that's not in the syllabus. Then temperature in Haber's process is 450 degrees Celsius. Liquid ammonia is known as refrigerant. Then the next is temperature in oxidation of ammonia is 800 degrees Celsius. And I think that's it. Let's move to the next question. Fill in the blanks from the choices given within brackets. Ammonia gas is collected by downward displacement of air. So just a second. Not this one. It's this one. Downward displacement of air. Nitrogen is prepared by heating the solution of ammonium chloride and sodium nitrite. The reaction involved in Haber's process is reversible, because if you remember, we put the reversible sign, and it is exothermic. So after the reactants are initially heated, you do not need to provide heat after that. The reaction is surviving on its own because it's an exothermic process. The next is ammonia is burnt in the atmosphere oxygen with green color. So you get a greenish flame. Ammonium salts react with alkalis to liberate ammonia. Let's move to the next one. Multiple choice questions. So you have the first one, chemical which is used as a drying agent for ammonia. So that is calcium oxide. Then the next is after this one, the next is the ratio by volume of nitrogen and hydrogen in Haber's process. So nitrogen to hydrogen, so NH3, you need 3 of hydrogens. So you're gonna go with C, that is 1:3. Promoter used in Haber's process is molybdenum. Saturated solution of ammonia in water. Okay, that's not in the syllabus. Nitrogen gas can be obtained by heating what? So you'll be heating ammonium nitrate. The next question is, okay, so we'll come back on this question. I want to do this question as the last question. So let's move forward to the next one. Name the gas evolved when the following mixtures are heated. So calcium hydroxide and ammonium chloride. So if we have done this in reaction, so when you have calcium hydroxide and ammonium chloride, you end up getting ammonia gas. So ammonia. The next is sodium nitrite and ammonium chloride. So in this case, you get nitrogen. You have nitrite. You end up getting nitrogen gas. The next is, this gas is used as a reducing agent in reducing copper oxide to copper. We have done this also. So that gas is ammonia. The next question is, this gas produces dense white fumes with ammonia gas. So that is your hydrogen chloride. Let's move to the next one. What do you observe when ammonia comes in contact with concentrated HCl? So that is dense white fumes can be seen. The next is, ammonia is passed over heated copper oxide. So the black colored copper oxide turns into a pinkish red metal. That's your observation. The next is, excess of chlorine gas is reacted with ammonia. So when we do that, you get a greenish color which disappears. So greenish yellow color disappears. Then the next is, a few drops of hydrochloric acid are added to silver nitrate solution, followed by addition of ammonium hydroxide solution. So a white PPT appears which is soluble in excess of ammonium hydroxide. Then the next is, when ammonia gas is burnt in an atmosphere of excess of oxygen, you get a greenish flame. That would be your observation. Alright students, let's get started with this last question for the day. This is an important question. I will be solving the first and second part, and the third part is homework. I want to see how many of the students are actually paying attention in the videos and if you're able to solve it on your own. So make sure that you try the third question and let me know the answer in the comment box, or you can send me an email on psclasses@icsc@gmail.com, or you can also reach out to me on the Telegram channel. But make sure that you try the third part on your own. So let's get started with the first one. Please pay attention on these questions because a lot of students get stuck in this, and these questions are very popular in ICSE board. So let's get started with the first one. So if you pay attention on the first one, I'll be going through the theory first and then we go ahead and write the equations. So the first thing is you're trying to move from ammonia to NO, nitrous oxide. So what will you do? You'll try and add oxygen to that. Okay, so you add oxygen to it in the presence of platinum at 800 degrees Celsius. So when that happens, you get NO. Now from NO, you have to move to NO2. So you again add up oxygen to it. So in the first case, you are adding oxygen here. Then in the second case also, you are adding oxygen here. You reach up NO2. Now from NO2, you are supposed to get HNO3, that is nitric acid. So for that, you will be adding water and oxygen together. So in this case, you are adding water and oxygen together. Then the D part is, from HNO3, you are trying to reach CuNO3 whole twice. So what will happen in this case is, you react with HNO3 with copper oxide, CuO. So from HNO3, you add up CuO with HNO3. So that will end up giving you CuNO3 whole twice plus water is liberated. So let's write these equations. So let's start with the first one. So A, always clearly write the answers, okay? So this is the A part. In A part, the A equation is ammonia to NO. So in this case, I am using the equation that is ammonia plus oxygen in the presence of platinum at 800 degrees Celsius. This is not a reversible reaction, I am sorry about that. This is a one-way equation. In the presence of platinum at 800 degrees Celsius, you get NO plus water. Then the next equation is the B one. From NO, you're supposed to reach up NO2. So you'll add up adding oxygen to it. So ammonia plus oxygen, sorry, not ammonia, NO. NO plus oxygen, you end up getting NO2. Then C part, from NO2, you're supposed to reach up HNO3. So in that case, you'll add water and oxygen, both of them together. So let's do that. So you have NO2 plus water plus oxygen, that will give you HNO3. Now let's move on to the next one. This was C. Now we are on D. From HNO3, you need to reach CuNO3 whole twice. So what you will do is, you will react HNO3 with copper oxide, that is CuO. So CuO plus HNO3 will give you CuNO3 whole twice, that is your required product, plus water comes out along with that. So this is your A part. Okay. Now let's come on B part. This looks slightly complicated, but if you try and pay attention on it, you will be able to get it. Okay. So let's look at the first one. I'm looking at A part. And let me change the color here. So I'm trying to work on A part. From ammonia, you're supposed to reach ammonium chloride. Now there are two ways to go with that. The first case is that you reacted with chlorine with ammonia in excess. So when you have ammonia in excess, you get NH4Cl. Or you can react ammonia with HCl, that is your hydrogen chloride. Then also you get NH4Cl. Okay. So either one of them. When I'm writing equations, I will write both of them. So one of the cases is you add HCl or you add chlorine. Any of them. Now let's move to B. So in this case, you're trying to reach NCl3. So again, you can react with chlorine being in excess. So when you have that, you end up getting NCl3. B is done. Now let's move on to C. From ammonia, you're trying to reach ammonium hydroxide. How will you do that? Just add water to it. So plus water. Correct? So you end up getting ammonium hydroxide. Now D part. So in D, from ammonia, you're trying to get nitrogen. So how would you do that? You end up adding oxygen to it. So when you add up oxygen without any conditions, you end up getting nitrogen. Okay. So you are adding oxygen here. Now from nitrogen, you're supposed to get back to ammonia. So what will you do there? So this is your basic Haber's process reaction. Nitrogen plus hydrogen gives you ammonia, but you have to make sure that you mention all the conditions. So in this case, just add hydrogen to nitrogen, you end up getting ammonia, the Haber's process reaction. Okay, we are done till E. After that we come on F. That is, from nitrogen you are trying to reach magnesium nitrite. So what would happen in that case? So you have nitrogen, you end up, what would you add up to that? So okay, so this is easy. So you have magnesium plus nitrogen, that will give you magnesium nitrite. Okay, so add magnesium to nitrogen. So magnesium plus nitrogen gives you magnesium nitrite. So I am adding magnesium here. Now from magnesium nitrite to ammonia, so this is a preparation reaction that we have already done. So you are using that particular concept only, that is warm water. Warm water. Alright. Now let's write these equations. So I am gonna find some space because I have to take up, like move it up and down for reference. Let's write it here. So equation A. In equation A, I am moving from ammonia to ammonium chloride, and I am taking both the cases. Once I am making with HCl, once I am making with chlorine. So let's write the first one. So first you have ammonia and you are trying to make ammonium chloride. Okay, let's start with this. So first thing you can do is, you can react this with chlorine with ammonia in an excess, which will give you ammonium chloride plus nitrogen gas. The second case is that, so I'll just write or you can say A. So you have ammonia plus HCl gas, that will give you ammonium chloride. Okay, now let's move to the B equation. Let's get back here. So B equation is from ammonia to NCl3. So again, the only combination that you have here is that you react it with chlorine. With chlorine in excess, you get NCl3. So let's do that. So you have ammonia plus chlorine in excess, that will give you NCl3 plus HCl. Let's move to C. So C is that you have ammonia and you're trying to reach ammonium hydroxide. So you just have to add water to it. So let's do that. Ammonia plus water will give you NH4OH. Then let's move to D. Alright, so from ammonia you're trying to get nitrogen. Okay, so how would you do that? You add up oxygen to it. So let's do that. So ammonia, from ammonia you're trying to reach nitrogen. Okay, so how will you do that? You add up oxygen to it. So plus oxygen, and that will give you nitrogen plus water. Plus water. Now D is done. Let's move to E. Alright, so E was from nitrogen you're trying to reach ammonia. So let's write that first. From nitrogen you're trying to reach ammonia. So how would you do that? From nitrogen trying to reach ammonia is very simple. That is Haber's process reaction. That is nitrogen plus hydrogen in the presence of molybdenum or iron at 450 degrees Celsius to 500 degrees Celsius at 280 M. That gives you ammonia, and that's a reversible reaction, so you have to make sure you make that arrow. So that is done. Let's move to F. Alright, F is from nitrogen you're trying to reach magnesium nitrite. So how would you do that? Nitrogen plus magnesium gives you magnesium nitrite. So let's write that. Magnesium plus nitrogen gives you magnesium nitrite. So one important thing, students, for these type of questions is that you don't have to so for example, when you see this kind of question, a lot of students are scared of trying it out. So my suggestion always is that whatever equations you know, you write those, because you still get marks for each equation. So even if you don't know, let's say 3 of them, but you do know 2 of them, make sure that you write that correctly, where which of the equation is that, A, B, C, D, E, F, which one that is, and what the equation is, and make sure you balance it out, because you do get marks for each part of it. So don't make that mistake. Now let's move to the last part, that is F. Then you have G. So from magnesium nitride you are trying to reach ammonia. So Mg3N2 Fg, Mg3N2, you are trying to reach ammonia. So this is a preparation reaction, that is add water to it, which is warm water. You end up getting ammonia plus magnesium hydroxide. So that is MgOH whole twice. So this is it for the second question. Now the third part, you can take a screenshot of it or you can download this link from the description box. Try this one on your own. I hope you have a better idea about how you're trying it, mix and matching, and try to do it on your own. If you're not able to, I will definitely make sure that I post a separate short video as an answer for this one. So make sure that you solve this on your own. Alright students, so this is it for today's session. We did do a lot of good level questions from ammonia today. So if these questions were your weak areas and you were struggling with these, I am definitely sure that this would help you out. Try out the third part, that one part of the question that I have not covered. Make sure you let me know the answers in the description box or on the Telegram channel, or you can write me an email on psclassesicsc@gmail.com. If you are facing any issues, you can also let me know, and I'll make sure that if you're not able to solve this out, I'll make a very short video for a few minutes just solving this one part of the question and I'll post it out. So thank you so much students. We'll catch up in the next session.